Hi everyone, my name is Mahan Rad. I am a technical specialist at Altair. In this short video, I'm going to show you how to simulate the impact of moving objects on the electromagnetic environment using Altair FEKO. Just a quick introduction about the scenario. Moving objects on a platform may change the electromagnetic environment significantly. Some examples are the variation of antenna pattern or introducing new source of interference. So the scenario that we are looking here is a helicopter with rotating blades, and we want to look at the effect of the blade rotation on the antenna pattern. The antenna is a simple monopole antenna operating at 150 megahertz, and these are the steps that are involved in the FEKO modeling. Some CAD techniques to create the moving objects, parametric modeling, parameter sweep, and finally results visualization. So I create a new CAD FEKO session, go to the component library and search for the helicopter. So this brings up the platform, click next and add the helicopter to the CAD FEKO session. So now when you look at the helicopter, you see it comes as one primitive part, which means that we really don't have access to those parts of the model, the blade part of the model, to rotate it. So we need to somehow recreate those section to be able to rotate it. So I change the selection type to the face selection, and then the selection method to rectangle selection method. Create a rectangle around the rotor blades to capture all the faces that create the rotor blades. So now all the faces are selected. I press Ctrl and K, so this will duplicate all those faces, and then I will union all those faces to create one part. So I duplicate the face, union them, and create a rotor blades as a separate part. So I'm renaming it here. So now I have the rotor blade. I hide it for now. We still have the blades on the original part. We need to delete that. So I select the helicopter and do the exact same thing. So create another rectangle around the blades on the original parts. All the faces are selected, and then press delete to remove them from the original part. So I have now the helicopter without the blades, and then blade part as a separate part. So next step is to create or define a variable. I add the angle as a variable, set some value, create the angle variable, and we want to rotate the blade part. So select the blade part and go to the transform tab and use the rotate function. So we want to rotate it around the center, so I set the origin to the center of the blade. Here I'm using the snap function, holding down the Control and Shift, highlight the points and snap to those points, set the rotation angle to angle variable that I just defined. And now if I go and change the value of the variable, you see the blade is rotating. So the platform comes with some wires for antenna, so we don't need those items. So I'm just deleting the wires that comes with the platform. We want to create our own antenna at this location. So again, here I'm using the component library, search for monopole, select the monopole antenna, click on next, set the frequency to 150 megahertz. The solution method is method of moment. We just need it for one frequency, single frequency. Don't need a ground plane, but we want to align it to that specific point. So in the align menu, just again, I'm using the snap function, hold down Control and Shift, and place the antenna at that specific location. So now I also added the antenna, all the necessary settings like the sources, the request, like far field requests, that they are all added. So here I'm selecting all these three parts, the blade, the antenna, and the helicopter, and union them. And again, testing the rotation function. So you see, just change the variable, and the blade antenna is rotating. So I'm running the parameter sweep here. So you just want to sweep one parameter or one variable, which is the angle variable. And there are different options here to run the sweep. I just go with the list of variables, and you can add as many as you like. Here we're just doing 4 instances of that variable, 4 different angles, and click next. So FEKO will create a separate CAD FEKO model for each of those angles, and once all models are created, it will run the simulation. At the end of the simulation, it will ask you if you want to run post FEKO. So here, if simulation is finished, asking if I want to run the post FEKO. So we enter yes, and so what it does, it populates all the results from different simulations in one post FEKO session, where we can look at all the results in one session. Here I'm creating an empty 3D view at the combined far field to this 3D view. On the right hand side menu, I have all the settings for this plot. Just change the scale to the dB scale, and here you see I can change the angle and look at the 3D pattern and how it changes. We can also do other forms of plot. Here I'm doing the polar plot, setting it to wrapped theta, change the scale to dB scale, and again changing the angle to look at the different radiation pattern. So that's basically one of the ways to look at the effect of the moving parts. Thanks for watching, and for more contents, make sure you follow Altair YouTube channel.